Okay, this is the third portion of lesson 4 in which we are talking about storage and memory. So let me ask you a question. How much memory is needed to store a page of text? We said that 1 byte can store 1 character. So a page of text is approximately 4,000 bytes, which is equivalent to 4K. K is kilobytes, so 1K is 1,000 bytes. Okay, so the next question is how much memory we need for a book of 400 pages. So this is simple. If we have one page that's 4K, then all we have to do is 400 times 4K, and we get 1600K, which is 1.6 megabytes. Megabytes, as you remember, is million bytes, or 1000 times 1000 bytes. So a book can be stored on 1.6 megabyte of memory. So now the next question is, if I have on my computer 256 gigabytes, how many books can I store on my computer? Let's say I have 250 to make it even. So what we have to do is we have to take this number and divide it into 1.6 megabytes and see how many books of 1.6 meg I can store in that disk drive. So if we do the division, 250 gigabytes or 250 billion bytes divide into 1,600,000, which is 1.5 megabytes, and that gives us 2.5 million books. So I can store on my laptop hard drive 2.5 million books. That's quite amazing for a small laptop. Now let's talk about the confusion of memory, which I mentioned before, and I'll show you why sometimes when they tell us that the disk is a certain size, the computer thinks it's a different size. Let's start from here. Remember, I said that the computer can count in binary and we count in decimal. So what happens is the disk makers produce disks and they give us the number or the size of the disk in the decimal system. So 1 megabyte, according to the disk makers, is 1,000,000 bytes. But according to the operating system of the computer, which knows binary, 1 megabyte would be 1024 times 1024, which gives a little bit more than 1,000,000. It gives 1,048,576. So when the disk maker tells you that you have a disk of 1 meg, you go on the computer and it tells you that you have less because it takes 1,000,000, divides it by 1,048,576 and gives you a smaller number. If we look here, I divided it, 1,000,000 divided by 1,048,576 gives only 0.953674 megabyte, not a full 1 megabyte. It's a fraction because the number in the denominator is higher than the number in the numerator. So 80 gig disk drive will generally show only 74 gig on the computer. And the calculation is, if you take a gig on the computer, you take 1024 times 1024 times 1024. So this number will come out to, take a small calculator and do it, 1024 times 1024 times 1024 will give 1,073,741,824. So the ratio that 1 gig on the computer will show is, if we take 1 billion and divide it into the 1 gig that we got from the computer system, which is 1,073,741,824. And this number will give us 0.931 approximately. So let's open a new page. So it's approximately 0.931. So now, in order to calculate, my hard drive, for example, is 256 gigabyte according to the manufacturer. So let's see how much the computer will give. If we calculate it, we'll have to multiply 256 times 0.931, and that will give approximately 238. Gigabytes. That's what the operating system says that I have, and the computer maker says 256. Now let's see if this is correct. Let me look at the information of my hard drive. I do get info, and I don't know if you can see it, it's pretty small, but it says capacity is 238.15 gigabytes. So approximately what we calculated, 256 gigabyte as per the manufacturer. The operating system says 238 gigabyte, and the reason is, as I mentioned before, because the computer operating system counts in binary, and binary is multiplications of 2, as we know. So 1000 is 1024, and when we multiply it several times, the ratio gives us less than what it says. You can check it on your computer. If you have Windows computer, you can do properties, and you can see that the disk capacity that you get is less than what the disk is supposed to be, and this is the reason for it. Anyway, if you read the Wikipedia article that I sent you the link for, it will explain you as well. So if something unclear, let me know with the email. And this ends our third portion of this fourth lesson, and next will be the fifth lesson at another day.